Imagine a sanctuary suspended in an endless freezing void, a delicate ribbon of space where the heat of a star is just gentle enough to let alien oceans flow. It is a precarious, invisible haven, a cosmic tightrope where the slightest deviation means boiling into suffocating vapor or locking into eternal crushing ice. This fragile threshold dictates the fundamental potential for everything that might eventually breathe, grow, or look back up at the night sky. Picture a world that does not spin in a perfect, peaceful circle, but instead plunges wildly toward its burning sun before fleeing back into the deepest dark. These eccentric, rhythmic journeys stretch the very limits of biological survival, forcing entire planets to weather explosive, boiling springtimes and devastating frozen winters. The destiny of these wandering spheres is an intricate, ongoing kinetic dance, surviving only by holding on to the memory of warmth during their long retreat. Surprisingly, even the host stars themselves are not permanent steady lanterns in this grand unfolding design. As these massive dynamic furnaces age and consume their nuclear fuel, their fires grow aggressively hotter, relentlessly pushing the boundary of life further out into the cold expanse. A world perfectly situated in the sweet spot today may have been a completely frozen wasteland for billions of years, waiting patiently for the advancing light to finally thaw its shores. Deep within the quiet sanctuary of your own room, you are entirely sheltered from these violent, shifting extremes of the universe. The heavy, comforting weight of your blankets holds you securely in a perfect, unchanging orbit, shielding you from the chaotic winds of the outside world. You are safe, and these breathtaking cosmic wonders are yours to inherit as you finally surrender to sleep. This quiet space around you requires nothing but your slow, steady breathing, matching the rhythmic pulse of a universe settling into equilibrium. As your body sinks deeper into the mattress, your mind is free to untether itself and float upward through the atmosphere, leaving the gravity of the day far behind. Your journey is just beginning, lifting you away from the Earth and out in the unfathomable depths of the cosmos, where a silent and precise geometry governs the potential for genesis. Out in the unfathomable depths of the cosmos, a silent and precise geometry governs the potential for genesis. The Goldilocks Zone represents that delicate, invisible ribbon of space encircling a star where conditions are perfectly tuned for liquid water to exist on a solid planetary surface. This is not merely an arbitrary boundary, but a profound intersection of stellar radiation and planetary thermodynamics. Within this specific orbital distance, a rocky world receives just enough warmth to prevent its primordial oceans from locking into eternal ice. The light from the host sun filters through the vacuum, striking the planetary crust with a gentle, sustained energy that allows water to pool, flow, and shape the landscape. It is a region defined by balance, where the extremes of the universe are temporarily held at bay. Here, the frozen comets melting into atmospheric vapor find a sanctuary, a place where liquid can settle into sprawling basins and vast echoing seas. This fragile ring of habitability is the ultimate cosmic sanctuary, a narrow haven suspended in an otherwise hostile and indifferent void. It dictates the fundamental potential for everything that might eventually breathe, grow, or look back up at the stars. To pinpoint this elusive haven, scientists must engage in an immensely complex calculation of energy exchange across the vacuum. Astronomers map this sweet spot by carefully balancing the raw, blinding stellar energy emitted by a sun against the specific amount of light a rocky planet reflects and absorbs. This intricate cosmic accounting depends heavily on the planet's albedo, the reflective quality of its surface and potential cloud cover. A world wrapped in bright white clouds will bounce a significant portion of its sun's heat back into the dark expanse, effectively cooling its surface. Conversely, a planet cloaked in dark, rugged basalt will eagerly drink in the radiation, holding the warmth close to its crust. The calculation is an ongoing equation of illumination and shadow, tracking how photons travel millions of miles only to be captured or rejected. By measuring these opposing forces, researchers can draw invisible borders around a star, marking where the math allows for temperate climates. It requires understanding not just the fiery furnace of the host star, but the geological and atmospheric character of the silent world orbiting it. Only when the absorbed energy perfectly matches the heat radiated away does a planet secure its place within the habitable threshold. Imagine walking out into a freezing pitch-black night and stepping toward a roaring, crackling campfire. As you approach the dancing flames, you instinctively seek the gentle gradient of heat, radiating from the core into the cool night air. You hold your hands out, feeling for that exact comforting distance where the thermal energy chases away the chill without searing your skin. This familiar earthly intuition perfectly mirrors the profound orbital mechanics governing planetary habitability. If you step too close to the glowing embers, the intense radiation becomes overwhelming, forcing you to retreat from the blistering, unbearable heat. If you back away into the shadows, the comforting warmth dissipates immediately, leaving you entirely to the mercy of the freezing dark. The planets in our universe are constantly seeking this exact same thermal equilibrium as they circle their burning stellar hearths. They must navigate the steep thermal drop-off of deep space, anchoring themselves in the soothing intermediate zone. That perfect distance provides the steady, nurturing warmth required to thaw the ice and sustain an open, liquid environment indefinitely. Venturing just slightly over that inner invisible line introduces an apocalyptic cascade of atmospheric consequences. Moving too close to the stellar fire turns a temperate world into a runaway greenhouse, a chaotic environment where oceans literally begin to boil away into the alien sky. The intense, punishing radiation excites the water molecules until the surface seas evaporate, packing the atmosphere with dense, suffocating water vapour. This airborne vapour acts as a heavy, inescapable thermal blanket, trapping even more of the star's heat and drastically accelerating the planetary fever. The rocks themselves bake under the unrelenting glare, releasing stores of primordial carbon dioxide that thicken the choking atmosphere even further. The once promising blue oceans are utterly eradicated, replaced by a hyper-pressurized toxic haze that completely blocks the surrounding cosmos. Venus stands as a grim, neighbouring testament to this devastating process, a world crushed under the weight of its own trapped, searing heat. The surface of such a planet is rendered into a sterile melting oven, completely devoid of the liquid sanctuary it once might have harboured. The inner edge of the habitable zone is therefore a strict, unforgiving boundary marked by ultimate desolation. Wandering beyond the outer limits of this temperate band plunges a world into a silent, perpetual winter. Drifting too far outward strips away the necessary warmth, allowing global glaciations to creep across the continents and freeze oceans entirely solid. The dying light of the distant sun becomes too weak to sustain the liquid cycle, failing to penetrate the deepening, encroaching cold. As the ice caps spread outward from the poles, their brilliant white surfaces reflect whatever meagre sunlight remains, accelerating the freezing process in a devastating feedback loop. Eventually, the entire globe becomes a blinding, frictionless sphere of solid ice, locking all potential chemistry within an impenetrable frozen vault. The atmosphere itself may begin to condense and fall as snow, leaving a thin, freezing vacuum in its wake. This icy fate echoes the desolate, windswept plains of our distant neighbours, like Mars, where the cold has reigned supreme for billions of years. Beneath miles of solid ice, the dark, crushed remains of what might have been sprawling oceans lie entirely dormant and still. It is a quiet, paralysed existence, where the energy required for fluid motion has been completely stolen by the indifferent depths of space. Strikingly, this zone of comfort is never truly permanent, but rather a breathing, evolving parameter tied to the lifespan of its star. This delicate band is not a fixed physical boundary, but a shifting, dynamic region that migrates outward depending on the age and temperature of the host sun. As a star consumes its nuclear fuel, its internal furnace burns hotter and brighter, steadily increasing its luminous output over billions of years. This escalating radiation pushes the inner and outer limits of the sweet spot further away, forcing the habitable region to slowly expand into the colder reaches of the system. A planet that formed in the perfect location during the star's youth might eventually find itself roasting as the thermal boundary marches relentlessly past its orbit. Conversely, a frozen world on the distant fringes may slowly thaw, awakening from an icy slumber as the expanding warmth finally reaches its shores. The geometry of warmth is thus a slow motion wave travelling through the planetary system, governed by the inexorable aging of the stellar core. It requires an observer to think not just in 3 dimensions of space, but in the vast, deep time of stellar evolution. Survival demands an orbit that can keep pace with this moving sanctuary, a cosmic alignment that must somehow endure the eons. Surprisingly, the universe is incredibly generous with these fleeting sanctuaries of potential life. Modern astronomical surveys have revealed that billions of these temperate regions are scattered across the sprawling spiral arms of our single galaxy alone. Almost every star burning in the night sky projects its own unique halo of warmth, creating a vast archipelago of habitable zones drifting through the Milky Way. When we stare up at the glittering canopy, we are looking at countless invisible rings where the temperature is exactly right for liquid water. This staggering abundance transforms the night sky from a cold, empty void into a crowded, fertile field of thermodynamic possibility. From the dimmest red dwarfs to the brightest yellow suns, each stellar furnace maintains its own specific territory of physical comfort. The sheer mathematical probability suggests that millions of rocky worlds are currently bathing in these gentle, temperate gradients. They are silent oases separated by light years of freezing darkness, yet bound together by the same fundamental laws of heat and distance. Our own blue marble is simply one fortunate beneficiary of a common, sweeping galactic phenomenon that echoes eternally across the cosmos. The ability to map these distant oases was born from centuries of painstaking, earthbound observation. Johannes Kepler first mathematically described the elliptical planetary orbits that make tracking these specific distances and thermal boundaries possible. By studying the precise movements of planets across the sky, he cracked the geometric code that governs how bodies swing around their central stars. His revolutionary laws revealed that planets do not move in perfect, unchanging circles, but rather in dynamic, sweeping ellipses that bring them closer to and further from the celestial fire. This foundational mathematics allows modern astronomers to predict exactly where a distant exoplanet will travel, and how long it will linger within the nurturing glow of its sun. Without Kepler's elegant equations, the shifting, complex dance of alien solar systems would remain an unreadable, chaotic blur. Today, we use these ancient principles to precisely calculate the orbital mechanics of worlds hundreds of light years away. By tracing their invisible elliptical paths, we can determine if they plunge dangerously close to the flames or drift completely into the freezing dark. It is a brilliant triumph of celestial mechanics, bridging the gap between a 17th century mathematician and the search for modern alien seas. Yet, existing within this flawless cosmic location is only half the battle for a burgeoning world. Even within this perfect temperate region, a planet requires the precise gravitational mass to hold onto an atmosphere capable of distributing the star's heat. A world that is too small lacks the necessary gravity to tether insulating gases to its surface, leaving it exposed to the harsh vacuum. Without a substantial atmospheric blanket, the sunlit side of the planet will scorch under the glare while the shadowed side plummets into absolute freezing darkness. The presence of a robust atmosphere acts as a planetary circulatory system, capturing the incoming radiation and gently blowing it across the terminator line to warm the frozen hemisphere. This delicate envelope of gas prevents catastrophic temperature swings, ensuring that the liquid water can remain stable across the globe. Furthermore, this atmospheric shield is essential for generating the atmospheric pressure necessary to keep water from instantly sublimating out into space. Thus, a world must be both perfectly placed and perfectly sized to harness the true potential of the Goldilocks Zone. It is an intricate, demanding recipe of mass, gravity and distance that must be perfectly balanced to maintain equilibrium. Deep within this intricate astronomical balance lies the foundational requirement for all biology, chemistry and life as we currently understand it. The gentle gradient of warmth, the precise orbital mechanics, and the heavy atmospheric blankets all conspire to maintain the fragile miracle of a liquid ocean. It is within these vast, churning bodies of stable water that the complex molecular dances of Genesis can finally take place. Without the liquid solvent provided by this celestial sweet spot, the necessary chemical reactions would remain eternally frozen, locked away in inert rock and ice. The Goldilocks Zone represents the universe's singular compromise, a rare pocket of tranquility where the brutal extremes of stellar fire and absolute zero are perfectly neutralized. It is the cosmic stage upon which the long, slow drama of evolution is permitted to unfold over billions of years. Every searching telescope, every spectral analysis, and every mathematical model is ultimately hunting for this exact, quiet equilibrium. Finding another world suspended within this perfect geometry of warmth is the first step to answering the oldest questions of our existence. It is the ultimate pursuit of finding a second home, hidden away safely in the comforting shadows of an alien fire. Nestled within those comforting shadows of an alien fire, the true architect of life begins its patient rhythmic work. Liquid water acts as the ultimate cosmic solvent, an active, flowing medium where the static elements of the universe are finally invited to mingle and transform. It is the great mediator of chemistry, gracefully stepping between inert molecules and coaxing them into the complex, energetic dances necessary for biological processes. If we were to look closer at a single shimmering drop, we would witness a microscopic arena of endless fluid possibility. The chemical structure of this liquid actively strips away the rigid bonds of solid matter, freeing individual atoms to float, collide, and seamlessly recombine. Without this fluid facilitator, the raw ingredients of existence would remain locked in a stubborn, unyielding state for all of eternity. Slowly, let your breathing align with the gentle rhythmic sound of liquid water lapping against a smooth stone shore. Every inhale draws in the cool, misty air of this alien ocean, while every exhale releases the tension from your resting body. As you sink deeper into the cushions beneath you, allow the steady, echoing wash of the waves to anchor your mind in this tranquil, submerged world. Picture a vast, planetary ocean relentlessly grinding against the rugged volcanic shores of a newly forged world. Over millions of years, the ceaseless motion of the crashing waves slowly dissolves essential minerals directly from the hardened rocky crust. Iron, magnesium and phosphorus are gently coaxed out of the fractured stone, bleeding into the water to create an incredibly rich, nutrient-dense brine. This gradual dissolving action transforms a barren global sea into a fertile primordial soup, brimming with profound biological potential. The ocean acts as a planetary-scale mixing bowl, churning the dissolved elements together under the dim, filtering light of a distant star. It is an environment where the heavy, solid geology of the world is methodically broken down and offered up to the delicate forces of organic chemistry. Deep within this swirling, mineral-laden broth, the first fragile precursors to cellular structures can finally begin to assemble themselves in the dark. The water provides both the essential building blocks and the protective cradle, sheltering these delicate new bonds from the harsh, abrasive physics of the open surface. A living world is fundamentally born not from the dry stone itself, but from the slow, dissolving embrace of the sea. The secret to this incredible transformative power lies entirely in the asymmetrical polarized shape of the microscopic molecule itself. Each tiny molecular structure possesses a distinct positive and negative charge, functioning exactly like a microscopic magnet wandering freely through the fluid medium. This unique polarity compels the molecules to naturally attract and fiercely stick to one another in an unbreakable fluid lattice. Because of this intense magnetic attraction, the liquid boasts an unusually high surface tension, allowing it to pool, bead, and cascade without instantly flying apart. It forms a cohesive, unified skin across the top of any ocean, a resilient, invisible barrier that cleanly separates the deep from the sky above. This identical chemical grip is what allows a drop of morning dew to stubbornly cling to a trembling leaf without immediately scattering into vapor. Furthermore, this intense molecular bonding gives the liquid an astonishingly high capacity to absorb and store thermal energy without prematurely boiling. The charge connections act like tiny invisible springs, absorbing the violent vibrations of stellar heat and distributing the kinetic energy safely throughout the entire fluid web. It is a brilliant microscopic architecture that makes bulk water one of the most stable and enduring substances in the physical universe. By absorbing these immense amounts of raw stellar radiation, deep planetary oceans act as the ultimate climate regulators for a temperate world. The sprawling, dark expanses of water soak up the blistering heat of the long alien day, holding it safely beneath the rippling sunlit waves. This massive thermal battery prevents the global atmosphere from instantly baking the continents into a dry, sterile husk when the sun is directly overhead. As the planet slowly rotates into the freezing darkness of the long night, the oceans gradually and generously exhale their stored warmth back into the cooling air. This measured release completely prevents the nocturnal hemisphere from plummeting into a sudden, catastrophic deep freeze that would shatter the fragile beginnings of biology. The liquid essentially acts as a planetary buffer, smoothing out the violent, swinging extremes of the local cosmos into a gentle, enduring hum. Notice how your own resting body naturally seeks a similar, quiet equilibrium, shedding the accumulated stress of the day and sinking into a state of thermal balance. The heavy, comforting weight of the blankets around you mimics this protective oceanic effect, holding your warmth close and shielding you from the cooler drafts of the room. Let the steady, even rhythm of your resting pulse echo the slow, regulating cycle of a global sea absorbing and releasing its ancient heat. Beneath the shimmering sunlit surface, colossal rivers of moving water continuously carve invisible, sweeping pathways through the pressurized, darkened depths. These massive global currents act as a planetary conveyor belt, continuously transporting immense volumes of captured heat from the scorching equator directly toward the frozen poles. The churning kinetic motion forces the warm, tropical waters to flow steadily northward and southward, fundamentally altering the climate of the entire globe. Without this ceaseless underwater circulation, the equatorial belt of a planet would boil endlessly, while its higher latitudes would remain locked in permanent, impenetrable ice. The winding currents effectively dilute the intense solar radiation of the equator, sharing the immense wealth of the star's energy with the darker, colder reaches of the world. It is a brilliant fluid distribution system that dramatically expands the habitable footprint of a rocky planet far beyond its narrow tropical center. Surprisingly, the complex twisting of these thermal rivers is driven entirely by the subtle changes in the water's own temperature and salinity as it travels. Cold, dense water sinks dramatically at the icy poles, creating a powerful, unseen vacuum that violently pulls the warmer surface waters up from the middle of the globe. This endless, churning engine operates in total silence beneath the waves, a masterpiece of fluid dynamics that dictates the atmospheric destiny of the skies above. In a bizarre and incredibly fortunate twist of physics, this liquid defies the standard rules of matter by actually expanding as it freezes into a solid state. Most substances in the known universe become significantly denser and heavier when they drop in temperature, but the polarized molecules of this fluid lock into a spacious, open crystalline grid. This structural anomaly beautifully dictates that solid ice is miraculously lighter than the liquid it forms from, causing it to float buoyantly upward to the surface. If we were to look closely at a freezing alien lake, we would see the ice forming a protective solid roof across the top rather than sinking to the dark bottom. This floating crust of frost creates a powerful insulating barrier, trapping the residual geothermal heat in the liquid below and shielding it from the freezing alien air. If ice were heavier than liquid, oceans would inevitably freeze solidly from the seafloor upward, instantly entombing and exterminating all delicate aquatic biology. Instead, the floating ice caps of a temperate world guarantee that a vast, dark and liquid sanctuary always remains hidden just beneath the frozen, windswept crust. The deepest, darkest trenches of an ice-covered moon can still harbour churning, fluid ecosystems perfectly protected from the freezing vacuum of space overhead. This single, quirky molecular property is perhaps the ultimate built-in failsafe for the continuation of biology in a fundamentally cold, indifferent universe. Descending into these lightless abyssal plains, we discover incredible environments where the liquid is violently heated from beneath rather than from above. Submarine hydrothermal vents frequently burst from the cracked ocean floor, spewing superheated, mineral-rich fluid straight into the crushing, freezing darkness of the deep sea. These towering, smoking, rocky chimneys thrive in waters that have never seen a single photon of starlight, offering a radically alternative theatre for Genesis. Here, the profound energy required to drive complex chemistry does not fall from the sky, but bleeds directly upward from the molten, churning heart of the planet itself. Bizarre alien ecosystems can flourish abundantly around these scalding fissures, perfectly adapted to harvest the volcanic heat and the toxic chemical soup billowing from the stone. They are completely blind, entirely self-sustaining oases of warmth and sustenance that do not care if the sun far above them burns brightly or extinguishes entirely. Take a moment to feel the steady, reassuring beat of your own heart, a quiet, internal engine driving the life and warmth continuously through your resting limbs. Like the geothermal vents hidden perfectly at the bottom of the world, your core provides a constant, unseen energy that sustains you regardless of the deepening darkness in the room. Allow the deep, slow rhythm of your chest to entirely sync with the steady, pulsing flow of the ocean's hidden volcanic springs. The constant, heavy presence of this surface liquid also reaches deep into the geological mechanics of the planet itself, far below the oceanic trenches. As continental tectonic plates violently crash and grind against one another, the infiltrating fluid acts as a crucial planetary-scale geological lubricant. The liquid seeps downward into the deep fault lines, dramatically lowering the melting point of the subterranean mantle and allowing the massive continental slabs to slide and gracefully subduct. This watery lubrication directly drives the very engine of plate tectonics, ensuring the crust remains a broken, shifting puzzle rather than a single, stagnant, unbreakable shell. As the old, carbon-heavy rock is pulled down into the fiery mantle, the resulting volcanic eruptions continuously recycle that vital carbon back into the open, breathing atmosphere. It is a slow, grinding breath of geology, a cycle of burial and fiery rebirth that is entirely dependent on the softening, relentless touch of the sea. Without the fluid greasing these colossal subterranean gears, the rocky crust would seize up permanently, completely halting the geological carbon cycle forever. The atmosphere would eventually thin out and vanish entirely, completely stripping the world of its insulating blanket and returning the surface to a barren, frozen wasteland. Thus, the liquid does not merely sit passively upon the rocks. It actively and aggressively participates in moulding the living, breathing architecture of the entire globe. Stripped of this simple, flowing molecule in its liquid state, even the most beautifully situated rocky planets quickly become stagnant, silent monuments drifting through space. The total absence of fluid means the absolute cessation of erosion, leaving jagged, ancient craters completely untouched by the softening hands of rain or a rushing river. The wind might howl across the dusty, barren plains, but without the transformative power of moisture, the landscape remains brutally static and permanently dead. Imagine a world where nothing ever dissolves, where chemical elements lie completely inert beside one another, unable to bridge the dry, microscopic gaps between them. The vibrant, chaotic mixing bowl of the primordial ocean is tragically replaced by a vast, unyielding desert of locked potential and completely frozen time. These dry spheres are essentially cosmic tombs, perfectly preserved records of violent impacts and ancient cooling, but entirely devoid of the chemical chaos required for biology. The universe is completely littered with these dry, dusty husks, worlds that orbit gracefully within the sweet spot but severely lack the essential solvent to awaken their chemistry. They are ghost ships sailing continuously through the perfect thermal gradients, waiting eternally for a torrential cosmic rain that will simply never arrive. It is a haunting, quiet reminder that location alone cannot spark the fire of existence without the fluid medium there to actually carry the flame. Therefore, the ultimate ambition of searching the distant, habitable cosmos is not merely finding the right temperature, but deliberately following the faint chemical trail of this specific liquid. Astrobiologists dedicate their entire lives to scanning the heavens for the unmistakable, spectral signatures of vapor glistening in the upper atmospheres of distant, unseen worlds. Finding the vapor is the first crucial clue that a massive liquid sanctuary might be quietly hiding in the dark shadows below the swirling clouds. Every telescope trained heavily on the night sky is essentially acting as a colossal cosmic divining rod, desperately searching the light years for the faintest drop of moisture. When a planetary spectrum finally reveals the heavy absorption lines of this exact molecule, the dead math of orbital mechanics suddenly blossoms into the vivid possibility of alien shores. It instantly transforms a distant glowing pixel of data into a tangible, a crashing ocean, waiting patiently to be discovered and explored. As you drift deeper into the quiet comfort of your resting space, remember that we are fundamentally beings of water, instinctively reaching out into the dark to find our own liquid reflection. The rhythmic sound of water gently lapping against a smooth stone shore is not just an earthly comfort, but the universal, enduring anthem of life itself. To find that beautiful sound echoing perfectly on another world is to finally confirm that we are not alone in the vast fluid dance of the cosmos. That vast fluid dance is ultimately choreographed by the massive burning entities that anchor every solar system. The central star acts as the celestial parent, dictating the climate, rhythm, and potential destiny of any world caught in its gravitational embrace. Our own sun is classified as a G-type yellow dwarf, a relatively calm and solitary sphere of plasma that provides a wonderfully wide and stable habitable region spanning millions of miles. This yellow glow radiates a highly balanced spectrum of energy, perfectly tuned to warm the planetary crusts without instantly stripping away their fragile atmospheres. The habitable band extending from a G-type star is remarkably forgiving, stretching comfortably past the orbital path of our own blue marble. This generous margin of error allows a planetary system a significant degree of architectural freedom, permitting multiple worlds to potentially share the same temperate sunlight simultaneously. If we were to look closely at the light bathing our own world, we would see a perfect mixture of visible, infrared, and ultraviolet rays. It is a nurturing, steady illumination that avoids the chaotic, destructive extremes found elsewhere in the galaxy. This specific yellow-tinted energy provides the absolute ideal baseline for long-term planetary stability, a steady heartbeat of warmth that has nourished biology for billions of years. However, Not all stellar parents are as patient or as gentle as the yellow dwarf we orbit. Notice how massive O-type and B-type blue giants burn furiously, projecting a harsh, blinding glare that pushes their habitable zones incredibly far out into the freezing void. These colossal behemoths are dozens of times larger than our Sun, generating surface temperatures so extreme that they radiate primarily in the deadly ultraviolet spectrum. Because of this terrifying heat, any planet hoping to maintain liquid water must orbit at a tremendous distant radius, far beyond where the gas giants in our system currently reside. At such immense distances, the concept of a year stretches into centuries, creating incredibly long, drawn-out orbital cycles. A world hovering in this distant blue-tinted sweet spot would look up at a tiny, piercingly bright sapphire in a pitch-black sky, completely dominated by its terrifying power. The energy output of a blue giant is not merely hot, it is violently intense. The sheer force of the stellar wind aggressively scours the surrounding space, making it incredibly difficult for a rocky world to hold onto a thick protective atmosphere. To survive near a blue giant, a planet must essentially cower in the deep outer shadows, seeking a precarious balance against an overwhelming cosmic fury. Tragically, these massive blue stars consume their nuclear fuel so rapidly that their temperate zones inevitably disappear before complex biology could theoretically evolve. The enormous gravity of an O-type star crushes its core with such intense pressure that it burns through its hydrogen reserves in a mere fraction of cosmic time. While a calm yellow dwarf might burn steadily for 10 billion years, a raging blue giant exhausts its entire lifespan in just a few million. This hyper-accelerated life cycle means the habitable region is fleeting, a temporary mirage that violently collapses just as quickly as it forms. Before the slow, methodical processes of planetary cooling, atmospheric formation, and primordial chemistry can even begin, the host star begins its catastrophic death throes. A world perfectly placed for liquid water will find its sun suddenly swelling into a red supergiant, completely obliterating the carefully balanced thermal gradients. Therefore, despite possessing massive sweeping habitable regions, these bright blue stars are considered absolute cosmic dead zones for the search for enduring life. They are beautiful, tragic fireworks, spectacular to observe from afar, but utterly incapable of nurturing a quiet, billions of years long biological history. The search for a living world must necessarily skip past these blinding jewels, seeking out the quieter, slower burning embers of the galaxy. Allow your eyes to remain softly closed, letting go of the harsh, blinding glare of those massive blue stars. Feel the gentle, supportive weight of the surface beneath you, grounding your body in the quiet stability of the present moment. Just as a world requires a calm and steady sun to thrive, your resting mind requires this peaceful, unhurried stillness to truly recover. Turning away from the giants, we find K-type orange dwarfs, which are slightly cooler and smaller than our Sun, yet offer an incredibly stable energy output for tens of billions of years. These modest stars emit a soft, enduring crimson glow, a comforting, warm light that lacks the aggressive, scorching ultraviolet radiation of larger stellar classes. Because they burn their fuel at a much more conservative rate, their lifespans stretch far beyond the age of the current universe. Furthermore, the habitable band around a K-type star is situated at a very comfortable intermediate distance. It is close enough to avoid the freezing depths of the outer system, yet far enough away to avoid the intense gravitational tidal locking common to smaller stars. This creates an incredibly balanced, peaceful planetary environment, a true cosmic haven where the clock of evolution is allowed to tick away peacefully for eons. For these exact reasons, many astrobiologists consider these orange dwarfs to be the true sweet spots for hosting long-term habitable worlds. While we naturally bias our search toward yellow stars like our own, the math strongly suggests that K-type stars offer a far superior, more stable biological real estate. They represent the ultimate cosmic compromise, possessing enough energy to spark chemistry, but enough patience to see it through to complexity. Imagine a lush, vibrant world bathed entirely in a permanent golden orange sunset, where the light is forever soft and deeply saturated. The native vegetation might evolve darker, richer pigments, perhaps deep reds or purples, to efficiently absorb this specific cooler spectrum of light. It would be a profoundly beautiful, enduring landscape, completely free from the violent solar flares or the impending death of its host star. If we are truly hunting for ancient, advanced biospheres, our telescopes should linger on these quiet, unassuming orange embers scattered throughout the galactic arms. They are the quiet, stable neighbourhoods of the universe, where the long, unbroken chains of biological history are most likely to survive the harsh realities of deep time. The ultimate sanctuary might not perfectly resemble Earth, but rather a world glowing softly under the eternal watch of a crimson sun. Stepping further down the stellar scale, we encounter M-type red dwarfs, which are definitively the most common stars in the universe, glowing with a dim, cool light that lasts for trillions of years. These tiny ancient furnaces make up roughly 3/4 of all the stars in existence, far outnumbering the bright yellow and blue giants combined. They're incredibly frugal, sipping at their hydrogen fuel so slowly that not a single red dwarf has yet died since the dawn of time. Because they are so prevalent, the statistical probability of finding rocky worlds is highest within the gravitational embrace of these tiny red stars. Their dim light casts a faint, deep red illumination, barely producing enough energy to warm a planet through the vacuum of space. To stand on a world orbiting an M-type star would feel like existing in an endless deep twilight, where the sun appears as a dull, glowing coal fixed in the sky. The sheer abundance of these stars makes them the primary focus of modern exoplanet hunting. If life is common in the universe, it most likely exists under the watchful, eternal glow of a red dwarf. They are the silent, enduring background noise of the galaxy, slowly burning away while massive empires of brighter stars rise and violently fall around them. As you breathe deeply, imagine the soft, enduring crimson glow of a red dwarf star washing over your resting limbs. Let the steady, ancient rhythm of that tiny stellar furnace match the slow, even pace of your own heartbeat. Sink further into the comforting shadows, knowing that true stability often comes not from blinding brightness, but from quiet, persistent endurance. Because red dwarfs are so inherently cold, their habitable zones are huddled extremely close to the star itself, creating a radically different orbital architecture. To receive the necessary warmth for liquid water, a planet must press itself tightly against the stellar fire, orbiting at distances far closer than Mercury is to our own Sun. This extreme proximity dramatically shortens the length of a planetary year, with worlds completing their entire orbit in a matter of mere days or weeks. This tight, cramped arrangement fundamentally alters the physical reality of the planets residing there. The gravitational pull of the nearby star is immensely powerful, constantly tugging and stretching the rocky crust of the orbiting world. This proximity creates a precarious existence, where the planet must balance the desperately needed heat against the overwhelming, crushing gravity of its tiny, dense parent. The sky of such a world would be dominated by the massive looming sphere of the red dwarf, taking up a significant portion of the horizon. The intimate dance between star and planet becomes inseparable, a tight spinning embrace that dictates every aspect of the world's geological and atmospheric fate. It is a habitable zone built on extreme claustrophobia, a sharp contrast to the wide, sweeping orbits found around brighter stars. If we were to look closer at early red dwarfs, we would discover a violent temper as they frequently unleash massive stellar flares that violently threaten to strip away these close planetary atmospheres. In their youth, these tiny stars are highly magnetically active, spontaneously erupting with terrifying bursts of X-rays and ultraviolet radiation. Because the habitable worlds are forced to orbit so closely, they take the absolute full, devastating brunt of these chaotic solar storms. A sudden flare from a young red dwarf can easily overwhelm a planet's natural magnetic defences, blasting the upper atmosphere with lethal doses of sterilizing energy. The sheer force of the incoming radiation violently heats the atmospheric gases, causing them to physically expand and boil away into the cold vacuum of space. Over millions of years, this relentless flaring bombardment can completely strip a world of its precious air, leaving behind a barren, irradiated rock. This violently active youth presents one of the greatest hurdles for habitability around the galaxy's most common stars. A planet might be perfectly placed for liquid water, but it must somehow survive an initial billion-year gauntlet of blinding radiation and atmospheric erosion. The deep crimson glow is often punctuated by blinding, deadly flashes, a chaotic infancy that heavily restricts the potential for delicate biological beginnings. Over billions of years, however, these tiny stars eventually calm down, providing an endlessly steady, reliable warmth to their surviving planets. The intense magnetic turmoil of their youth gradually subsides, replaced by a quiet, monotonous burning that will last for trillions of years into the future. If a rocky world can somehow cling to its atmosphere through the violent early epochs, it is eventually rewarded with the most stable, enduring environment in the known universe. The chaotic flaring gives way to a permanent, gentle heating, allowing the surviving oceans to finally settle and stabilize under the deep red sky. This incredibly long, peaceful maturity offers a timescale for evolution that completely dwarfs the lifespan of our own solar system. Life on such a world would have near infinite time to adapt, recover from setbacks, and slowly perfect its complex biological machinery without the threat of stellar interruption. It is a profound narrative of survival and patience, where the chaotic, dangerous beginnings eventually yield to an eternity of quiet, uninterrupted grace. The oldest, most advanced biospheres might currently reside around these ancient, pacified red dwarfs, having weathered the storms of their youth eons ago. They stand as testaments to the sheer resilience of atmospheres and the enduring, patient nature of the cosmos itself. Ultimately, each specific type of star paints its habitable zone with a completely different, unique spectrum of light, from intense ultraviolet to deep infrared. The colour of the host star fundamentally dictates the available energy palette that any potential biology must utilise to survive. Photosynthesis, the foundational process of converting light into living energy, must radically adapt to match the specific wavelengths beaming down from the alien sky. A world orbiting a yellow sun utilises visible light, driving the green, chlorophyll-rich landscapes we're so intimately familiar with. However, a planet bathed in the cool glow of a red dwarf would receive almost entirely infrared radiation, useless to earthly plants but perfectly viable for alien, black-leafed forests designed to harvest the darker heat. Conversely, life surviving the intense glare of a hotter star might develop protective, reflective pigments, painting the continents in blinding whites or deep ultraviolet-absorbing blues. The Goldilocks Zone, therefore, is not a uniform, identical environment replicated across the galaxy, but a highly variable canvas dictated entirely by the stellar parent. The light that warms the water also colours the potential biology, ensuring that the universe is filled with a wildly diverse, unimaginable array of living tapestries. We're not just searching for water, we're searching for the specific, unique flavour of light that might be feeding the strange, beautiful forests of the dark. In those strange, beautiful forests of the dark, the very concept of a day is fundamentally rewritten by the relentless, invisible grip of cosmic gravity. Planets orbiting closely within the narrow habitable zones of red dwarfs often find their rotation ground to a halt by the immense tidal pull of their parent star. This phenomenon, known as tidal locking, occurs because the star's gravity creates massive physical bulges in the planet's rocky crust, exerting a constant drag that eventually synchronizes the world's rotation with its orbital period. Over millions of years, the planet stops spinning relative to its sun, settling into a permanent unmoving orientation where one face is eternally bonded to the light. This gravitational embrace is so powerful that it dictates every aspect of the world's existence, from the flow of its winds to the potential for its biology. It is a world where the motion of the heavens has been traded for a static, unwavering loyalty to the host star. Between these two warring hemispheres lies a thin ribbon of perpetual twilight, a sanctuary known as the Terminator Line that serves as the global frontier. This narrow band divides the burning, sun-facing desert from the encroaching global ice sheet that covers the dark side of the planet. In this specific region, the sun sits forever on the horizon, casting long, unmoving shadows across a landscape caught in a state of eternal dusk. It is perhaps the most temperate and inviting region on the entire planet, acting as a Goldilocks strip nestled within the Goldilocks Zone itself. Here, the temperature gradients are at their most balanced, allowing for a climate that is neither too hot to boil nor too cold to freeze. It is a world of long violet shadows and soft orange light, a place where the air finally finds a moment of relative peace. Take a moment to feel the stillness of your own body, mirroring the unmoving landscape of this alien twilight world. Just as the Terminator Line finds its balance between fire and ice, allow your mind to find its own calm center between the noise of your day and the silence of the night. Let the weight of your limbs sink further into the surface beneath you, feeling as steady and permanent as the shadows on this distant alien shore. Your breathing remains slow and rhythmic, a quiet internal clock in a world that has forgotten the sun also sets. Surprisingly, the atmosphere of such a world is anything but still, as powerful and continuous winds howl across the Terminator Line in a desperate attempt to achieve thermal balance. The intense heat of the day side causes the air to rise and rush toward the freezing night side, creating a global circulation engine of staggering proportions. These winds act as a massive high-speed heat transfer system, carrying essential warmth into the darkness to keep the night-side atmosphere from freezing completely onto the surface. Without this relentless, screaming gale, the air on the dark side would simply turn to liquid and fall as nitrogen rain, leaving the planet airless and dead. The sound of this world is the sound of a permanent hurricane, a ceaseless roar of air trying to heal the divide between the heat and the cold. It is a violent, necessary turbulence that keeps the heart of the world beating in the face of absolute darkness. This intense atmospheric circulation might also create permanent, massive cloud covers directly facing the star at the substellar point, the place where the sun is always at high noon. As the rising warm air cools and condenses, it forms a gargantuan stationary storm system that acts as a natural planetary parasol for the world below. This brilliant white shield reflects a significant portion of the excess heat back into space, preventing the day side from becoming an uninhabitable melting furnace. By self-regulating its own temperature through these massive cloud decks, the planet creates a localized environment where liquid water can endure despite the proximity to the stellar fire. From space, this world would look like a giant clouded eye staring back at its sun, protected by a white iris of shifting water vapor. It is a masterpiece of atmospheric self-preservation, a shield of mist held up against a crimson glare. If we were to look closer at the edges of the Terminator, we might find liquid water sustained by a unique, planetary-scale recycling program. The constant melting of the encroaching night-side glaciers, fueled by the heat bleeding over from the dayside, could create vast, shallow lakes and meandering rivers within the twilight band. This moisture is continually replenished, as the atmospheric winds carry vapor back into the darkness to freeze once again, maintaining a delicate fluid balance. These lakes would be perfectly still, reflecting the unmoving red sun on their surfaces like mirrors of dark glass. This slow, cyclical dance of ice and melt ensures that a stable reservoir of liquid remains available for whatever chemistry might take root in the soil. It is a quiet hydraulic engine that functions without the need for rain, powered entirely by the temperature difference between the light and the dark. Notice the slow, even rhythm of your own breathing, a quiet cycle that continues even when the world outside feels perfectly still. Unlike the inhabitants of a twilight world, your body thrives on these subtle repetitions, finding comfort in the steady, familiar rise and fall of your chest. Let each breath carry you further into a state of deep, unmoving relaxation, as stable and enduring as the eternal sunset on the alien horizon. You're perfectly grounded, perfectly calm, and perfectly at rest in the stillness. Deep within the shadowed valleys of the Terminator, alien vegetation would likely adapt to harvest the plentiful infrared light provided by the red dwarf. To capture these low-energy photons, the leaves of these alien forests would appear in startling shades of pitch black or deep, bruised purple rather than the green we know. Such dark pigments are necessary to absorb as much energy as possible from a sun that glows more like a dying ember than a vibrant flame. Walking through such a forest would be a surreal experience, where the foliage feels heavy and warm to the touch, drinking in the invisible heat of the static sky. The trees would likely grow in distorted, low-slung shapes to resist the constant howling winds that rake the twilight band. It is a dark, warm garden of shadows, a landscape painted in the colours of the deepest night. This unique structure gives rise to what astronomers call eyeball planets, which present one of the most alien yet statistically common environments where liquid water might pool. Viewed from space, the planet resembles a giant celestial eye, with a dark pupil-like storm at the substellar point and a white sclera-like ice sheet covering the rest of the globe. Because red dwarfs are so numerous, these tidally locked oases are likely some of the most frequent habitable environments in the entire Milky Way galaxy. They are strange, static monuments to the power of gravity over rotation, proving that life can find a sanctuary even in a world that has forgotten how to spin. They remind us that the definition of habitability is vast and varied, reaching into the shadows where we once thought only ice could exist. These eyeball worlds watch their stars with an unblinking gaze, waiting for the slow chemistry of time to fulfill its promise. That promise of a liquid sanctuary is held in the balance by the precise, rhythmic motion of a planet's path through the void. While we often envision planetary orbits as perfect, unchanging circles, the reality of the cosmos is far more fluid and eccentric. Most worlds follow elliptical trajectories, routinely drifting closer to their host stars in a warm embrace before retreating into the deeper, colder reaches of their solar systems. This constant oscillation creates a physical sensation of swinging closer to a radiating heat source, only to slowly retreat into the biting chill of the distant dark. The gravitational tug of other planets and the initial chaos of a system's birth ensure that perfect circularity is a rare cosmic exception rather than the rule. Consequently, a world must find its stability not in a fixed distance, but within the varying speeds and distances of an elliptical journey. It is a rhythmic breathing of the planetary body, expanding and contracting its relationship with the light over millions of miles. This movement dictates the very pulse of the environment, forcing the atmosphere and oceans to adapt to a changing influx of energy. In this kinetic reality, the world is never truly still, but always in a state of falling and returning. Deep within these elongated paths, the climate of a world becomes a story of dramatic transition rather than static stability. A highly eccentric orbit can physically drag a planet completely out of the Goldilocks Zone during the peak of its deepest winter or the height of its most searing summer. For part of its year, the world may bask in perfect temperate warmth, only to find itself cast out into a freezing abyss where the star's light becomes a distant, ineffective glint. The planet's oceans might begin to glaze over with ice as the distance from the sun grows, threatening to lock the world in a permanent frost. However, As the orbital curve brings the world hurtling back toward the stellar furnace, that ice is violently challenged by an overwhelming surge of radiation. This extreme seasonal cycle forces any potential biology to endure conditions that swing between the boiling point and absolute zero. Such worlds exist on the edge of a knife, where the definition of home is a fleeting window of time rather than a permanent location. The atmospheric chemistry must be incredibly resilient to survive being stretched to its physical limits by the changing geometry of the system. It is a precarious existence, where the survival of liquid water depends on a planet's ability to weather the storms of its own trajectory. If we were to look closer at the survivors of these extreme orbits, we would find they rely on the immense insulating power of a dense atmospheric blanket. A sufficiently thick envelope of gas can capture and store the intense thermal energy gathered during the planet's close approach to the star. This stored heat serves as a life-preserving reservoir, allowing the surface to resist the encroaching frost as the world embarks on its long, lonely journey into the outer darkness. The molecules of the air act as a thermal storage system, holding on to the infrared energy and slowly releasing it to keep the oceans liquid during the long winter. This prevents the global temperature from plummeting into a state of total, irreversible glaciation before the next approach begins. Without this protective shroud, the surface would be scoured by the vacuum and the ice would never have a chance to thaw. This atmospheric buffering is the primary defense against the eccentricities of the heavens, a shield of gas that smooths out the jagged edges of an elliptical year. It transforms a world of impossible extremes into one of manageable, albeit dramatic, seasons. The air is the memory of the sun's warmth, carrying the light of the perihelion into the shadows of the aphelion. Surprisingly, this process functions much like a gargantuan thermal flywheel, maintaining planetary momentum against the devastating gaps of extreme cold. The atmosphere and oceans act as a massive kinetic battery, spinning with heat that persists long after the stellar furnace has receded into the distance. It is a brilliant mechanism of resilience, bridging the seasonal gulfs to ensure that the spark of biology is never fully extinguished by the void. This thermal inertia means that the coldest point of the planet's year often occurs long after it has passed its furthest point from the star. The world carries its warmth like a heavy cloak, slowly shedding it as it wanders the outer rim, waiting for the gravitational snap to pull it back toward the fire. It is a testament to the power of matter to retain the energy of the light, even when the source has grown small and dim. Let the steady warmth of your own resting body serve as a reminder of this internal regulation, a quiet fire that burns regardless of the air around you. As you settle deeper into your surroundings, feel the slow, rhythmic persistence of your own heat, an enduring glow that bridges the moments of stillness. You are your own thermal flywheel, a stable presence in a world of shifting temperatures. This structure of orbital motion can lead to worlds with highly elliptical paths experiencing brief, explosive springtimes that defy all earthly comparison. As the planet hurtles back toward its sun, frozen oceans that have been dormant for years may suddenly and violently melt under the rapidly intensifying glare. In a matter of weeks, a world of silent ice can transform into a churning, steaming cauldron where surface waters briefly boil before the planet swings away once more. These violent thaws create massive global floods and atmospheric upheavals as the latent heat of the star reawakens the world's hydraulic cycle. The sudden transition from absolute stillness to chaotic motion triggers enormous storms and geological shifts that reshape the entire planetary landscape. It is a rebirth characterized by fire and steam, a frantic awakening that must make use of every second of the fleeting summer. For any life clinging to such a world, these explosive windows of liquid water are the only opportunity for growth and reproduction. The biological clock must tick at an incredible pace, synchronizing its entire existence with the brief, searing visit to the inner system. It is a life lived in the fast lane of the cosmos, a desperate race against the inevitable return of the ice. Surprisingly, the destiny of a small rocky world is often determined by the invisible, gravitational hands of its much larger and more powerful neighbours. Gravitational interactions with massive gas giants can gradually nudge a planet's chaotic elliptical path into a more stable, circularized orbit. This slow celestial choreography effectively tethers the world permanently within the temperate band, shielding it from the seasonal extremes that would otherwise prevent the rise of complex life. Through a series of subtle gravitational tugs, the gas giant drains the eccentricity from the smaller planet's path, smoothing the ellipse into a circle. This process, which can take millions of years, represents a transition from a world of chaos to a world of predictable, enduring warmth. The giant acts as a cosmic stabilizer, its massive weight ensuring that the smaller world stays exactly where the water can thrive. Without these giant guardians, many rocky worlds would remain trapped in orbits too extreme for biology to ever find a foothold. The presence of a Jupiter-like planet can be the difference between a world of seasonal death and a stable, blue oasis. It is a partnership of giants and dwarves, a gravitational harmony that creates the conditions for a lasting peace. Conversely, the migration of Jupiter-like giants can act as a violent disruption, casting smaller, rocky worlds out of the habitable zone entirely. As these massive entities spiral inward toward their stars during the early stages of a system's formation, their immense gravity acts like a cosmic slingshot, destabilizing everything in their path. A world that was once a flourishing oasis can be abruptly flung into the dark interstellar vacuum, left to wander the galaxy as a frozen, lonely rogue. This process, known as planetary scattering, can also push a world too close to the star, where it is eventually consumed by the stellar fire or stripped of its atmosphere. The migration of a giant is a catastrophic event for smaller planets, a reshuffling of the deck that leaves very few survivors in the temperate zone. It reminds us that the Goldilocks Zone is a contested territory, subject to the whims of the system's most massive inhabitants. Those worlds that remain in the zone after such a migration are the lucky few who have navigated a gauntlet of gravitational fire. They stand as survivors of a chaotic history, their stability earned through the violent expulsion of their siblings. The peace they enjoy is a hard-won silence, a calm that exists only because the giants have finished their dance. The tilt of a planet's axis also plays a crucial role in distributing the precious warmth received while the world passes through the optimal region. This slant ensures that starlight is spread across different latitudes, preventing the equator from bearing the full, unmitigated brunt of the stellar fire. It creates the familiar cycle of seasons, a rhythmic shifting of climate that stirs the atmosphere and prevents planetary stagnation. Without this tilt, a planet would be locked in a permanent, unchanging weather pattern, where the poles are forever frozen and the equator is forever scorched. The axial slant acts as a global mixing paddle, ensuring that no part of the world is left entirely in the dark or entirely in the heat. It is a subtle geometric detail that has profound implications for the diversity of environments and the movement of life. Notice the gentle rise and fall of your own breath, a rhythmic movement that, like the tilt of a world, ensures that vitality is shared evenly throughout your being. With every inhalation, you bring in the new, and with every exhalation, you release the old, maintaining a perfect balance within your own physical system. Let this internal season guide you into a state of deeper relaxation, where every part of you is warmed by the steady flow of your own life. The atmosphere on such a world must work overtime to transport heat from the sun-drenched pole to the one shrouded in a 30-year night. Massive global-scale storms would dominate the climate, driven by the temperature difference between the side in eternal summer and the side in eternal dark. It is a world where day and night are measured in decades, and where the sun never sets for an entire generation. Life here would have to be incredibly specialized, perhaps migrating thousands of miles to stay within the retreating light, or entering a deep metabolic sleep to survive the decades of frost. The surface would be a landscape of extremes, where the geography itself is shaped by the relentless, unmoving glare of a sun that refuses to leave the sky. It is a testament to the fact that even in the perfect orbit, the orientation of a world can make it feel like an alien abyss. The concept of habitability is therefore revealed to be far more than a matter of simple, static location. It is an intricate and ongoing kinetic dance. A world must navigate the shifting pressures of gravity, the fluctuations of its own path, and the tilt of its body to maintain its delicate thermal equilibrium. It is a performance that requires constant motion and perfect timing, a symphony of physics played out across the vast, dark stage of the heavens. We see that a living world is not a fixed destination, but a beautiful, moving target that must stay in sync with the forces around it. The Goldilocks Zone is not a place you find, but a balance you keep, a state of being that is earned through the constant movement of the cosmos. Every world in this zone is a dancer, spinning and weaving through the gravity of its neighbours and the light of its star. As you conclude this part of the journey, let the realization sink in that your own existence is part of this grand, kinetic harmony. You're part of a world that has mastered this dance, a world that has found its rhythm in the vast, silent dark. Rest now in that stability, knowing that the music of the spheres is playing all around you, holding you exactly where you need to be. Staying exactly where you need to be within the orbital sweep is a profound achievement, but position alone is a silent promise, without the presence of an atmospheric veil. Even the most perfectly placed rocky world is essentially useless to the prospects of life if it lacks a gaseous shell to capture and retain the passing starlight. Without this invisible container, the energy of the star strikes the surface and immediately bounces back into the infinite hungry vacuum. It is the atmosphere that transforms a simple rock into a vessel for planetary warmth. This gaseous layer acts as a cosmic sieve, selectively trapping the thermal photons while allowing the world to breathe against the void. A world in the habitable zone without an air supply is like a hearth, without a room to hold the heat. The fire burns, but the space remains deathly cold. Earth serves as a masterful example of this delicate atmospheric engineering, relying on mere trace amounts of carbon dioxide and water vapour to maintain its lush, temperate state. While our air is dominated by nitrogen and oxygen, it is these rare greenhouse gases that perform the heavy lifting of thermal regulation. They act as microscopic mirrors, catching the escaping infrared radiation and reflecting it back toward the surface with relentless efficiency. Surprisingly, these vital components make up only a tiny fraction of the total atmospheric volume, yet their influence is absolute. They are the fine-tuned settings of a global thermostat, ensuring that the planet's energy budget remains in the black. This thin chemical lace is the only thing standing between a world of crashing waves and a world of silent, frozen stone. If we were to look closer at the molecular scale, we would see these gases vibrating with captured energy, a silent hum of warmth that permeates every corner of the globe. They ensure that even when the sun dips below the horizon, the ground beneath our feet retains the memory of the light. It is a subtle, invisible mechanism that demonstrates how the smallest ingredients can dictate the fate of an entire world and the survival of every organism that calls it home. Without this mild and persistent greenhouse effect, our brilliant blue marble would inevitably succumb to the creeping chill of deep space, becoming a completely frozen snowball regardless of its ideal orbit. The global temperature would plummet far below the freezing point of water, locking the continents under miles of unyielding ice and reflecting what little sunlight arrived back into the abyss. The oceans would cease their rhythmic tides, and the vibrant colours of our world would fade into a singular, blinding white. This realization highlights the fragility of the perfect distance we often celebrate in astronomical models. Orbit is only the beginning of the story. The internal chemistry of the air is what finishes the narrative of survival. The greenhouse effect is not a modern anomaly, but an ancient and essential safeguard that has kept the spark of life from being extinguished by the cosmic dark. Notice the heavy, comforting weight of the air as you rest, a thick quilt of pressure that holds you in place and keeps the cold at bay. Just as your body relies on the layers around it to maintain its core vitality, the Earth relies on its gaseous shroud to survive the frigid reality of its surroundings. Let this sense of protection settle over you, grounding you in the profound safety of our planet's ancient invisible blanket. Consider for a moment a rocky world situated at the very outer edge of a habitable zone, a place where the star's light is weak and the shadows are long. To maintain liquid water at such a distance, the planet requires a massive exotic atmosphere composed of dense hydrogen or heavy concentrations of heat-trapping gases. This super greenhouse effect would need to be powerful enough to amplify every megaphoton of starlight into a sustainable surface temperature. Under such conditions, the air would be thick and pressurized, creating a world where the sky might glow with the trapped energy of a distant sun. The landscapes would be shrouded in heavy mists, and the weather patterns would be dominated by the intense heat-trapping properties of the molecular hydrogen. It would be a world of deep, humid warmth, existing in a place where physics suggests only ice should remain. This structure of habitability proves that the boundaries of life are wider than we once dared to imagine. It is the atmosphere that dictates the limits of the sweet spot, pushing the frontier of the Goldilocks Zone further into the dark than distance alone would allow. In the far reaches of a solar system, a planet's air is its only hope for an enduring liquid heart. If a planet is too small, its weak gravitational grip will inevitably fail to anchor its protective atmospheric blanket against the harsh, scouring force of the solar wind. The stream of charged particles flowing from the host star acts like a cosmic sandblaster, relentlessly stripping away the outer layers of a world's gas. Over geological time, the molecules that would have provided warmth are carried away into the void, leaving the surface exposed and vulnerable. This atmospheric erosion is a slow, silent theft that transforms potential oases into barren, airless wastelands. The planet may start with the right ingredients, but its lack of mass becomes its ultimate undoing. Without the weight to hold onto its shroud, the world loses its ability to regulate its own temperature, falling victim to the unmitigated extremes of the local star. Deep within this dynamic, we see that mass is a prerequisite for habitability, a physical anchor that secures the gaseous quilt. A planet must be just right not only in its location, but in its substance, possessing the strength to defy the wind. Only the heavy and the grounded can hope to maintain a stable, living environment across the billions of years required for evolution to take root and blossom. Magnetic fields act as vital, invisible shields in this struggle for survival, deflecting the lethal charged stellar particles that would otherwise erode the precious insulating gases over time. This magnetosphere serves as a planetary armor, a swirling cage of magnetic force that diverts the solar storm around the world like water around the bow of a ship. It protects the atmospheric quilt from being shredded by the high-energy radiation that pours from the stellar furnace. As you lie still, feel the quiet, unseen forces that keep your own internal environment in balance. Your heart beats in a rhythm you rarely notice, much like the spinning core of a world, providing the energy that sustains your outer peace. Let your mind drift on the thought of these invisible layers of protection, shielding you from the noise and pressure of the outside world, allowing you to rest in perfect safety and profound tranquility. This runaway process began when the early oceans of Venus boiled away, releasing even more heat-trapping vapor into the sky. The feedback loop became unstoppable, a cycle of warming that transformed a potential sibling of Earth into a hellish landscape of volcanic gloom. The clouds of Venus are not a protection, but a heavy thermal lid that ensures no heat can ever escape back into the cooling dark. Mars resides near the outer edge of our system's habitable band, but it lost its protective magnetic field in the deep antiquity of its youth, leading to a tragic decline. Without that shield, the solar wind was free to strip away the Martian atmosphere, reducing the once thick blanket to a mere ghost of its former self. The result was the catastrophic freezing of its surface and the loss of its sprawling ancient oceans to the void. If we were to look closer at the Martian landscape, we would see the dry riverbeds and empty basins that once held the liquid promise of a living world. Today, the air is so thin that liquid water would instantly boil or freeze, unable to exist in the low pressure of the modern surface. Mars is a world that ran out of time, its internal dynamo dying before it could secure its long-term atmospheric health. This historical collapse proves that the Goldilocks Zone is a fleeting privilege for those who cannot defend their air. The loss of the magnetosphere was the death knell for Martian habitability, turning a potential oasis into a cold, dusty monument to what might have been. It is a silent witness to the necessity of internal vigour in the maintenance of an external sanctuary. The specific chemical composition of the air dictates whether a planet perfectly placed in the zone becomes a flourishing oasis or a desolate, toxic wasteland. It is not enough to simply have air. The recipe of that air must be meticulously balanced to support the complex requirements of chemistry and life. The presence of oxygen, methane, and nitrogen in the right proportions creates the breathable, insulating mixture that allows a world to truly thrive. If the air is too rich in sulfur or ammonia, the world may be warm, but it will be hostile to the very life it seeks to nurture. The atmosphere acts as a chemical filter, choosing which energies and elements reach the surface and which are barred from entry. This chemical character is the final layer of the Goldilocks puzzle, the signature of a world that is truly ready for the spark of Genesis. Notice the gentle, cool air entering your lungs with every breath, a perfect mixture that sustains your life without a thought. This invisible fuel is the result of billions of years of planetary refinement, a chemical gift that you participate in every second of your existence. Let this connection to the atmosphere ground you, a reminder that you are part of the very air that wraps our world in its protective, life-giving embrace. A planet ultimately creates its own localized Goldilocks zone by wrapping itself in the correct mixture of reflective clouds and heat-trapping gases. This self-generated microclimate allows a world to exist comfortably, even if its host star is slightly too dim or its orbit is slightly too distant. Through the clever use of its atmospheric blanket, a planet can push back the boundaries of the freezing dark and carve out a space for itself in the light. The clouds act as a dynamic, shifting shield, reflecting excess radiation when the star flares and trapping heat when the system cools. It is a living, breathing system of regulation that allows the world to maintain its liquid heart against the odds. The planet does not just inhabit the Goldilocks zone, it actively maintains it through the architecture of its own sky and the chemistry of its breath. This structure reveals the profound agency of the worlds themselves in the search for habitability. A planet is not a passive recipient of stellar warmth, but an active participant in the creation of its own temperate reality. Wrapped in its gaseous quilt, it stands defiant against the cold, a localized miracle of balance and warmth in the vast, silent dark of the universe that stretches out to the very edge of everything. Deep within that vast, silent dark, we often find colossal sentinels that redefine our understanding of the habitable zone. Massive gas giants like Jupiter possess no solid surfaces upon which liquid water could pool or chemistry could find a stable footing, even when they orbit squarely within the temperate band of a star. Their immense gravity creates crushing pressures and turbulent atmospheric layers that would pulverize any biological structure before it could begin to replicate. While these giants are breathtaking to observe, with their swirling bands of ammonia and perpetual storms, they remain indifferent to the delicate requirements of life as we know it. They are fluid, chaotic entities, lacking the terrestrial foundation necessary for a biosphere to take root. Every potential for genesis in these systems must look elsewhere, toward the smaller, firmer worlds that follow in the wake of the giants. Surprisingly, these behemoths are not alone in their journey, acting as massive gravitational anchors for extensive retinues of rocky and icy satellites. While the giant planet itself may be a sterile abyss of gas, Its orbiting moons often possess the solid crusts and diverse mineral compositions that the host lacks. Many of these satellites are small, terrestrial worlds in their own right, capable of sheltering surface oceans or thick atmospheres under the right conditions. This creates a secondary tier of habitability within a single solar system, where a single gas giant can carry a dozen potential oases through the void. It is a crowded, complex architecture that transforms a single candidate into a localized cluster of possibility. The universe utilizes these giants as cosmic buses, transporting a multitude of worlds into the warmth of the stellar hearth. If we were to look closer at such a moon, we would witness a dual-source energy system that challenges the standard model of stellar warmth. An exomoon orbiting within the Goldilocks Zone receives heat not only from the primary star but also from the bright reflected light of its massive gas giant host. This secondary illumination, known as planet shine, provides a constant, soft radiance that can significantly bolster the moon's surface temperature even when its face is turned away from the sun. During the moon's night, the giant planet remains a looming, glowing presence in the sky, preventing the atmosphere from plummeting into a total deep freeze. This architectural synergy allows a moon to stay temperate, even if it sits slightly further from its star than a standalone planet would dare. It is a world of two suns, one a distant point of fire and the other a vast banded shield of reflected light. Tidal forces generated by the immense unrelenting gravity of the gas planet constantly knead the moon's interior, generating deep volcanic heat through friction. As the moon follows its slightly elliptical path, the massive pull of the giant planet physically stretches and compresses the satellite's rocky core, much like a ball of clay being worked in a pair of giant hands. This relentless internal friction provides a steady geothermal energy source that can sustain active volcanism and warm the planetary crust from the bottom up. It is a subterranean furnace that operates independently of starlight, ensuring the moon's heart remains molten and vibrant throughout the eons. Let the steady, rhythmic warmth of your own body remind you of this internal persistence, where the core sustains the whole. As you sink deeper into your resting space, feel the quiet energy circulating through you, a silent engine of vitality that never truly stops. This hidden, internal friction is powerful enough to sustain liquid subsurface oceans, even if the primary star's light is relatively weak, or the system resides in a distant cold reach of the galaxy. Beneath miles of protective ice, the constant tidal heating prevents the water from freezing solid, creating dark, pressurized sanctuaries that are entirely insulated from the vacuum above. These abyssal seas are some of the most stable environments in the universe, shielded from solar flares, asteroid impacts, and the shifting luminosities of aging stars. Within these lightless oases, life could potentially thrive on chemical energy alone, harvesting minerals from hydrothermal vents on the sea floor. The Goldilocks Zone thus expands from a surface measurement to a three-dimensional depth, where liquid water is kept alive by the gravity of a giant neighbour. It is a profound realization that the most common habitats in the cosmos may be the ones hidden forever from the light. This structure of life leads to the breathtaking possibility of a lush, forest-covered moon that must endure regular and prolonged eclipses. As the satellite passes behind the immense shadow of its colossal gas giant host, the sun is completely blotted out, plunging the entire world into a deep, temporary twilight. During these eclipses, the temperature would drop and the bioluminescent flora of the alien forest would begin to glow, painting the landscape in ethereal blues and greens. These rhythmic cycles of shadow and light would dictate the evolutionary strategies of any native species, forcing them to adapt to periods of intense stellar radiation, followed by long stretches of cool, planet-lit darkness. It is a world governed by the silhouette of a giant, where the sky is dominated by a swirling, banded majesty that never leaves the horizon. Standing on such a shore, you would watch a continent-sized shadow sweep across the stars, marking the heartbeat of your world. Conversely, those same magnetic fields can act as a deadly trap, capturing and accelerating charged particles into a lethal radiation belt that bombards the Moon's surface. If the Moon orbits too closely to its giant parent, it becomes caught in a permanent storm of high-energy electrons and ions that can penetrate deep into the crust, shattering organic molecules and sterilizing the landscape. This creates a precarious distance within the satellite system itself, where a moon must be far enough to avoid the radiation, but close enough to benefit from the tidal heat. The presence of a giant planet is a double-edged sword, offering life-saving protection in one orbit and radioactive doom in another. It is a delicate balance of planetary placement, where the invisible forces of the giant can either nurture a garden or incinerate a world. The very shield that saves one world may be the anvil upon which another is broken. Surprisingly, finding these potential exomoons remains incredibly difficult for modern telescopes, as their tiny silhouettes are almost entirely lost in the overwhelming glare of both the star and the giant planet. To detect a moon, astronomers must witness a transit within a transit, looking for the minute dip in light caused by a satellite passing in front of its already transiting host. The signal is so faint and the timing so complex that we have only just begun to identify the first few candidates among the thousands of known exoplanets. Our current view of the universe is like looking at a distant lighthouse and trying to spot a moth circling the lantern. The brilliance of the primary sources masks the presence of the smaller, more interesting worlds. Yet, our inability to see them does not diminish their likely abundance, as we know from our own solar system that moons are far more numerous than planets. We are currently blind to the most populated real estate in the galaxy. Mathematically, there may be vastly more habitable moons in the universe than there are habitable standalone planets, suggesting that the primary home for life in the cosmos could be a satellite. Because gas giants can easily migrate into the Goldilocks Zone and carry dozens of rocky moons with them, the number of temperate environments multiplies exponentially with every giant we discover. This realization shifts the focus of astrobiology from the search for another Earth to the search for worlds where gravity and internal heat replace the simple reliance on starlight. We are beginning to understand that the universe is a place where life is not just a singular miracle on a lonely rock, but a frequent occurrence in the diverse neighborhoods of giants. Let the realization of this vast hidden abundance bring a sense of expansive calm to your resting body, as if you were part of an infinite thriving network of light and life. Every breath you take is an echo of a much larger cosmic rhythm that stretches across every moon and every star in the dark. This cosmic rhythm, which carries us through the vast and silent dark, reveals that habitability is a nested grace. Entire galaxies, those majestic spinning cities of light, possess their overarching habitable zones that dictate where life can truly anchor itself among the billions of suns. This macro-scale sweet spot is determined by a complex interplay between the density of stars and the local availability of heavy chemical elements forged in ancient stellar hearts. It is not enough for a single sun to be gentle and steady. The entire galactic neighborhood must provide the raw materials for rocky crusts, while remaining free from the most violent outbursts of the galactic engine. This expansive realization shifts our gaze from the individual planet to the grand architecture of the galaxy itself, seeking the specific regions where the music of the spheres is not drowned out by cosmic noise. Deep within the glittering, chaotic core of the galaxy, the sheer density of suns creates a landscape of terminal beauty and absolute, unrelenting danger. Frequent supernovae erupt in these crowded central regions, bathing the surrounding space in lethal doses of sterilizing gamma radiation that can strip the atmosphere from any nearby planet in a single terrifying heartbeat. These cosmic explosions are so common near the center that the interval between them is often shorter than the required time for complex chemistry to even begin its first tentative steps toward life. It is a region of blinding, destructive light, where the local energy is too intense and too volatile to permit the slow, patient crawl of biological evolution. In this high-energy wasteland, the stars are packed so tightly together that their radiation overlaps, creating a global environment of scorched rock and sterile vacuum. The violent gravitational turbulence of this crowded centre also creates a lethal mechanical lottery for any world attempting to maintain a stable, temperate path. Close encounters between passing stars are so frequent that planetary orbits are routinely disrupted, torn away from their host suns by the immense tug of a neighbouring giant passing through the system. These orphaned worlds are then flung into the freezing, lightless interstellar void, destined to wander the dark as rogue planets, forever disconnected from any source of life-giving warmth. In the heart of the galaxy, the very geometry of a solar system is a fragile and temporary arrangement, easily shattered by the chaotic movements of the surrounding stellar crowd. This constant orbital reshuffling ensures that even if a world found a perfect location, it would likely be evicted before a single ocean could form. Surprisingly, the opposite extreme at the far, quiet edges of the galactic rim offers its own set of insurmountable barriers to the formation of a living world. Out in these sparse, quiet outer reaches, the ancient stars are composed almost entirely of primordial hydrogen and helium, remnants of a time before the universe had birthed its more complex components. These stars lack the heavy metals and silicates that were forged in the massive hearts of previous generations, leaving the surrounding space curiously empty of solid, rocky matter. If we were to look closer at these lonely suns, we would see a landscape of gas and light, but no solid shores upon which an alien ocean could ever break. Feel the stillness of your own hands and the solid weight of your resting body, realizing that the very atoms you're made of are cosmic rarities that do not exist in the vast, empty suburbs of the galaxy. These outer regions are fundamentally impoverished, lacking the essential iron, carbon and oxygen required to construct the solid rocky planets and complex organic biology we recognize. Without the heavy ash of dead stars to provide the building blocks of crusts and cores, these systems remain ghost-like and ethereal, unable to provide a terrestrial home. There are no iron-rich hearts to generate magnetic shields, and no carbon chains to weave into the delicate fabric of a living cell. The edges of the galaxy are a quiet, beautiful desert of pure gas, where the recipe for life is missing its most vital and substantive ingredients. This vacuum of material ensures that even the most perfect orbit around an outer star remains a barren journey through a void of potential. It is a stark reminder that we are the children of stardust, born from a material wealth that the rim simply cannot afford. Our own solar system resides in a remarkably fortunate position, tucked securely within the middle of the Milky Way's disk, far from both the explosive core and the empty rim. We are located in what astronomers often call the galactic suburb, a region rich enough in heavy elements to build massive rocky worlds, but sparse enough to avoid the radiation storms of the centre. This specific placement provides us with a just right environment on a truly gargantuan scale, balancing the availability of resources with the necessity of safety. It is a peaceful, well-stocked harbour in a sea of cosmic extremes, offering the perfect baseline for a multi-billion-year biological experiment. By living in this intermediate band, we benefit from the history of our galaxy without being consumed by its current violent activity. This quiet galactic location allows our sun to orbit the distant galactic centre in a stable, nearly circular path that has remained largely undisturbed for billions of years. Because we are far from the crowded core, we avoid the gravitational nudges that would otherwise destabilize our planetary system and send us spiraling into the dark or the fire. This consistency is the silent foundation of our history, providing a steady environment that has allowed the Earth to maintain its delicate thermal balance across geological epochs. It is a grand, slow-motion journey through the stars, a celestial rotation that guarantees a predictable and safe neighbourhood for the life growing on our surface. Notice the slow, even pace of your heartbeat, a rhythmic certainty that mirrors the grand, stable orbit of our sun through the galaxy. Let the calm regularity of your breathing remind you that true growth requires this kind of enduring, uninterrupted peace. We carefully navigate the galaxy by avoiding the most densely packed spiral arms, where violent gravitational encounters and intense radiation spikes are dangerously common. These arms are the regions of active starbirth, crowded with massive, short-lived giants that frequently end their lives in catastrophic explosions. Our Sun resides in a relatively clear gap between these major structures, moving at a speed that allows us to stay within these safe zones for nearly the entire history of our planet. This precise timing is no small feat. It is a cosmic game of avoidance that has kept us out of the path of the galaxy's most destructive weather. If we were to look closer at the map of our journey, we would see we are travelers on a long winding back road, staying clear of the dangerous highways where stars collide and die. The concept of a habitable zone thus scales dramatically up from a single solar system to the macro structure of the entire galaxy itself. We must view the search for life not just as a hunt for a planet at the right distance from its sun, but as a search for a solar system at the right distance from its galactic centre. The universe operates in nested layers of habitability, where each stable island of warmth must also be situated within a stable sea of stars. This realization expands the Goldilocks principle into a three-dimensional map of galactic potential, marking the specific regions where the chemistry of life is even possible. Surprisingly, the universe reveals that being in the right place is a fractal requirement, demanding perfection at every scale from the atomic to the galactic. Ultimately, the perfect conditions for life require a peaceful neighbourhood on a cosmic scale just as much as an optimal distance from a warming sun. A planet could be perfectly sized and perfectly placed within its own system, yet still be rendered sterile by the local environment of its host galaxy. True habitability is a rare alignment of multiple favourable conditions, from the microscopic polarity of water to the gargantuan rotation of the galactic disk. We are the survivors of a long list of cosmic prerequisites, residents of a quiet corner of a vast spinning city that has provided us with everything we need to flourish in the dark. Let the realization of this immense supportive structure settle into your consciousness, providing a sense of deep cosmic belonging as you rest in the center of a perfectly balanced universe. In this perfectly balanced universe, we have developed the means to eavesdrop on our most distant neighbours by watching the way their suns illuminate them from behind. Astronomers observe planets in the Goldilocks Zone by capturing the faint filtered starlight that passes through the thin, transparent layers of an alien atmosphere during a transit. As a world glides in front of its host star, the atmosphere acts like a delicate cosmic lens, absorbing and scattering specific wavelengths of light before they reach our terrestrial senses. This minuscule dip in brightness carries with it the chemical identity of the world, a spectral message travelling across trillions of miles of empty space. By analysing this filtered glow, we can detect the presence of gases that would otherwise remain invisible to our most powerful optical cameras. The starlight serves as a massive natural backlight, revealing the silhouette of the air itself as it wraps around the rocky curve of the planet. It is a process of extreme precision, requiring us to measure a change in light equivalent to a single firefly passing in front of a searchlight. Within that tiny fraction of a percent, the secrets of an entire environment are hidden, waiting for the patient decryption of our distant mirrors. This method allows us to reach across the void and sample the air of a world we may never physically visit. Specific airborne molecules absorb certain colours of light with absolute mathematical predictability, leaving dark and recognisable barcodes in the stellar spectrum we receive on Earth. Every element, from water vapour to carbon dioxide, possesses its own unique optical signature that subtracts specific frequencies from the star's white light. When we pass this light through a prism, the resulting rainbow is missing thin, vertical lines where the alien atmosphere has reached out and snatched those photons for itself. These missing strips of colour function as a universal language, telling us exactly what the air is made of without needing to touch a single atom of the planet's surface. If we were to look closer at these spectral barcodes, we would find a detailed inventory of the planet's atmospheric health and potential for life. A world rich in water vapour will show a distinct pattern of absorption, while the presence of ozone or methane will leave their own unmistakable marks on the light. This technique, known as transmission spectroscopy, transforms the abstract distance of space into a tangible chemical reality. It allows us to distinguish between a dry, airless rock and a humid, cloud-shrouded oasis by simply reading the shadows left behind in a beam of starlight. We are essentially deciphering the chemical fingerprints of the cosmos, one wavelength at a time. We actively search for biosignatures, which are chemical imbalances in an atmosphere that can only be maintained by the constant active metabolism of living organisms. In a dead world, chemistry naturally drifts toward a state of equilibrium, where all reactions have finished and the air becomes a stable, inert mixture. Life, however, is a chaotic and energetic force that constantly pumps new gases into the sky, forcing the atmosphere into a state of permanent, high-energy disequilibrium. Finding a planet whose air is out of balance is the primary clue that something biological is working tirelessly on the surface below. These signatures are the chemical equivalent of a heartbeat, proving that the world is actively breathing rather than just sitting in silent geological stagnation. Surprisingly, the sheer scale of this chemical interference can be detected from across the galaxy, provided our instruments are sensitive enough to pick up the signal. On Earth, our massive forests and churning oceans keep our atmosphere flooded with gases that would otherwise vanish in a matter of centuries. When we look for biosignatures elsewhere, we are looking for that same persistent biological defiance of the laws of entropy. It is a search for a world that refuses to be still, a place where the air is a living testament to the complexity hidden beneath its clouds. By identifying these imbalances, we find the unmistakable footprints of life written in the very air of distant solar systems. Surprisingly, the chemical relationship between oxygen and methane is one of the most powerful indicators of an active biosphere. These two gases react destructively with one another, quickly turning into carbon dioxide and water if they are not constantly replenished by external sources. Finding both of them together in significant quantities strongly implies that something on the planet is actively and continuously producing them at a rate that outpaces their natural destruction. On our own world, plants produce the oxygen while bacteria and animals produce the methane, creating a chemical tension that has persisted for eons. Detecting this same, impossible mixture in an alien sky would be a revolutionary confirmation of biological activity. Notice how non-biological processes like intense ultraviolet light breaking down water vapour can create false oxygen signals that deeply confuse our most careful readings. In a process called photolysis, the high-energy radiation from a star can rip water molecules apart, leaving the lighter hydrogen to escape into space, while the heavier oxygen lingers in the atmosphere. This can create a sky rich in oxygen that has absolutely nothing to do with photosynthesis or living organisms, leading us to believe a world is habitable when it's actually a sterile, desiccated desert. Distinguishing between this abiotic oxygen and the oxygen produced by life requires us to look at the entire context of the planetary system. Notice the gentle, rhythmic expansion of your own lungs as you rest, a steady movement of oxygen that is the result of a living, breathing planet. As your chest rises and falls, feel the weight of your body settling further into the stillness of your environment, mimicking the stable, quiet atmosphere we hope to find. Let your mind drift on the thought of these invisible gases, realizing that your own breath is a part of a global chemical story that stretches back billions of years. You're a participant in the very biosignature we are searching for in the dark, a living piece of evidence in a vast chemical mystery. Identifying artificial pollutants like industrial chlorofluorocarbons would suggest the presence of an advanced, technological civilization residing squarely in the sweet spot. These molecules, often used as refrigerants or propellants, do not occur naturally in any known geological or biological process in the universe. Finding them in a planetary spectrum would be an unambiguous signal that a technological society has emerged and has begun to alter its atmosphere through industrial activity. These techno-signatures would be the ultimate proof that we're not only looking at a living world, but an intelligent one that has mastered its environment. It would turn a distant dot of light into a recognizable mirror of our own civilization. If we were to look closer at the light from such a world, we might even find signs of nitrogen dioxide or other industrial smogs that indicate a thriving, energy-consuming population. These chemical whispers would be a message across time and space, proving that the Goldilocks Zone can produce more than just simple microbes. It suggests that the same path of evolution and discovery we have walked is being echoed elsewhere in the galactic disk. Such a discovery would fundamentally change our place in the cosmos, proving that the atmosphere of a planet can be a canvas for technology as much as for biology. We're searching for the chemical echoes of a neighbour's industry, listening for the sound of a civilization breathing through its sky. The James Webb Space Telescope currently scans the atmospheres of temperate red dwarf planets, looking for these incredibly delicate chemical whispers with unprecedented clarity. Its massive gold-coated mirrors are designed to capture the faint infrared light that carries the signatures of molecules like carbon dioxide, methane and water. By staring intently at systems like TRAPPIST-1, it is performing a planetary census of our nearest neighbours, trying to determine if they possess the air required to host life. This orbiting observatory is our most powerful tool for seeing through the dark, a technological eye that can perceive the chemical makeup of worlds hundreds of trillions of miles away. It represents the pinnacle of our current ability to interrogate the heavens. This telescope does not look for high-resolution images of alien continents, but for the subtle, shifting patterns of light that indicate a hidden atmosphere. Every hour it spends pointed at a distant star is an attempt to peel back the layers of the unknown and reveal the truth of a distant world. It is a mission of extreme patience and incredible data processing, where a few stray photons can tell a story of global oceans or volcanic plains. The James Webb is currently rewriting the textbooks of astrobiology, proving that the chemical whispers of the universe are louder and more frequent than we ever dared to imagine. It is our scout in the dark searching for the first confirmed signs of a second home. Even a completely dead world in the habitable zone will show signs of carbon dioxide, offering vital clues about its ancient volcanic history and its potential for past warmth. This gas is a common product of planetary outgassing, the process where molten interiors release their trapped elements through fissures and volcanic vents. Finding carbon dioxide tells us that a planet has an active or recent geological heart, providing the internal energy that drives the circulation of matter. It is a sign of a world that is geologically alive, even if its surface remains a sterile and desolate wasteland. The presence of this gas is the first step in understanding the long-term climate stability of a rocky world in the sweet spot. Allow your breathing to slow to a deep, effortless pace, feeling the quiet stability of your own internal systems as they maintain your resting state. Just as a planet uses its geological gases to regulate its temperature over eons, your own body maintains its balance with every silent heartbeat and every steady breath. Let the stillness of your surroundings ground you in the realization that life and geology are inextricably linked in the quest for survival. You are part of a world that has mastered this chemical cycle, a living witness to the success of a perfectly balanced atmosphere. Rest in that certainty, feeling the quiet power of a world that has kept its oceans liquid for 4 billion years. True verification of a living world requires a complex combination of atmospheric data, orbital parameters, and a deep understanding of photochemistry to avoid a false positive. We cannot simply rely on the detection of a single gas like oxygen. We must understand how that gas interacts with the star's light and the other molecules in the sky. If the star is a red dwarf, Its intense ultraviolet flaring can create a chemical environment that looks like life, but is actually driven by high-energy physics. To be certain of our discovery, we must look at the whole planet as a system, balancing the orbital distance against the atmospheric pressure and the chemical ratios. It is a holistic detective story, where every piece of data must fit perfectly into the larger narrative of habitability. This rigorous process ensures that when we finally declare a world to be inhabited, we do so with the highest possible scientific certainty. We must account for the way a planet's gravity holds onto its air and the way its surface minerals might be absorbing or releasing specific gases. It is a grand exercise in cosmic cross-referencing, comparing our distant observations with everything we know about the laws of nature. The search for life is thus a search for consistency across all levels of physical reality, from the movement of the planet in its orbit to the microscopic vibration of its gas molecules. Only when all the evidence points in a single biological direction can we say we have truly found another Earth. The ultimate proof of a second Earth will not be a high-resolution photograph of green continents or blue oceans, but a simple graph of light showing the unmistakable breadth of an active biosphere. This graph, showing the peaks and valleys of various absorption lines, will be the most beautiful image in the history of science. It will reveal a world where oxygen and methane dance together in defiance of entropy, and where the temperature is held steady by a protective gaseous blanket. To a trained eye, these lines on a screen will be more vivid and meaningful than any picture, for they represent the tangible chemistry of a living, breathing neighbour. It will be the final synthesis of our search, the moment the abstract math of the Goldilocks Zone becomes a living reality. This light curve will be the unmistakable evidence that we are part of a larger, thriving community of worlds scattered throughout the galactic disk. It will show the chemical whispers of another civilization, or the ancient biological hum of a primordial forest, reaching across the void to find us. When that graph finally appears on our monitors, it will be the culmination of centuries of human curiosity and technological progress. We will realize that the universe is not just a collection of cold stars and empty rocks, but a vast chemical laboratory where life is the most precious and frequent experiment. That single graph will be the unmistakable proof that we are truly at home in a perfectly balanced universe, a world among many, breathing in the dark. As we breathe in the dark of this perfectly balanced universe, we find that even the light itself is a moving target. Stars are not static, eternal lanterns, but dynamic and aging furnaces that grow noticeably hotter and more luminous as they consume their nuclear fuel over eons. This internal evolution is driven by the inexorable conversion of hydrogen into helium, a process that steadily increases the pressure and temperature at the stellar core. Consequently, the Goldilocks Zone is never a fixed territory, but a temperate border that slowly and inexorably marches outward into the cold reaches of the planetary system. This slow-motion migration means that the sanctuary of liquid water is constantly being pushed further away from the star's surface. A world that once basked in the perfect glow of its youth may eventually find itself roasting as the thermal boundary overtakes its orbit. The music of the spheres is thus a shifting melody, its sweet spot drifting across the void like a beam of light moving through a dark hall. We are searching not just for a stable place, but for a world that can keep pace with this advancing fire. It is a relentless, million-year chase between the movement of the planet and the expansion of the star. Surprisingly, even a world that sits in the perfect heart of the sweet spot today may have been a completely frozen wasteland for billions of years beforehand. For the vast majority of its long history, such a planet likely sat beyond the reach of the fire, locked in a cryostatic silence, where the oceans were merely mountains of lightless ice. Only as the host star brightened and the habitable zone migrated outward, did the first rays of transformative heat finally reach those distant, frigid shores. This late-blooming spring represents a massive geological and chemical awakening, as the global ice caps retreated and the liquid cycle began for the very first time. The world awakens from a multi-billion-year slumber, its chemical potential finally unlocked by the advancing light of its aging parent. It reminds us that habitability is not necessarily a birthright from the moment of formation, but a phase that must be earned through the slow progression of stellar age. Many worlds we see in the temperate band today may be newborns in terms of their climate, just starting a journey that we are already far along. Their ancient history is written in the deep frost of a dark age that has only recently ended. They are oases that have just begun to bloom in the desert of time. This progression toward the light means that our own cradle is ultimately outpaced by its own source of life. Earth itself will eventually be left behind as the increasing heat of our host star pushes the inner edge of the habitable zone entirely past our current orbit. The delicate balance that has sustained our lush environment for 4 billion years is a temporary arrangement on the immense scale of cosmic time. In the distant future, the sun will swell and its radiation will intensify, turning our blue oceans into a thick, suffocating shroud of atmospheric steam. The cradle of humanity will eventually become a baked and barren rock, watching as the sweet spot of liquid water drifts toward the outer giants and the frozen moons. We are residents of a vanishing oasis, a world enjoying a long and beautiful afternoon that will one day fade into a searing evening. This realization gives our presence here an incredible poignancy, a sense of living within a precious and finite window of planetary grace. We are the beneficiaries of a long stability that is slowly and inevitably coming to an end. It is a quiet reminder to cherish the liquid state of our world while the window remains open. Notice the slow, inexorable ticking of the clock within your own biology, the quiet movement of time measured by each steady heartbeat. Just as a star measures its age in the fusion of its core, your body marks its presence in the gentle, consistent flow of internal vitality. Feel the warmth of the surface beneath you, and let the tension drain from your limbs as you surrender to the profound stillness of the present. Deep within this shifting landscape lies the concept of the continuously habitable zone, the incredibly narrow band where conditions remain stable for the billions of years life needs to evolve. Most planets only graze the habitable band, entering and exiting the sweet spot too quickly for biology to reach any significant complexity. To remain Goldilocks for the long haul, a world must occupy a precise, stable region that the migrating boundaries do not quickly bypass. This is the ultimate biological real estate, a thin sliver of space that offers the gift of time as much as the gift of heat. It is here, and only here, where the slow, painstaking climb from microbes to minds can truly take place. A planet must be perfectly anchored in this corridor to see the biological drama through to its final act. Surprisingly, the climb to complexity is a multi-billion-year process that cannot be rushed by any amount of chemical luck. It is a sobering fact that life on Earth took roughly 4 billion years to transition from simple single cells to the complex intelligence that now questions the stars. For 3/4 of our history, the planet was a world of invisible, microscopic life, slowly and methodically tinkering with the machinery of energy and DNA. We are the survivors of an incredible endurance test, the heirs to a legacy of patience that stretches back to the very cooling of the crust. The clock of life moves at a glacial pace, demanding a world that can wait out the eons without losing its liquid heart. Our consciousness is the result of 4 billion years of uninterrupted planetary warmth. This requirement of endurance means that short habitable windows might spark the first flickers of simple life, but never produce forests or creatures. The stellar furnace brightens too quickly, or the planetary atmosphere fails too soon, closing the window before the biological drama can reach its second act. These worlds are cosmic tragedies, places where the fire was lit and the potential was high, but the fuel ran out before the flame could truly take hold. They may be filled with ancient, single-celled fossils buried deep in the silent stone, but they will never know the rustle of leaves or the sound of a voice. They are unfinished symphonies of existence, worlds that were given the right start but denied the time to reach their glorious conclusion. A planet must not only find the sweet spot, but it must possess the stamina to stay there through the shifting winds of stellar evolution. Without that endurance, the most promising oasis becomes a biological graveyard, a testament to a spring that never reached its summer. The universe is likely littered with these half-finished biological experiments, worlds that ran out of time. They are silent witnesses to the necessity of deep time in the creation of a living world. Let the stillness of your environment settle over you like a thick protective blanket, insulating you from the noise of the outside world. Feel the quiet stability of your own resting state, a sanctuary where the rush of the world is replaced by a deep and profound calm. Just as a planet seeks the stability of a narrow zone, your mind finds its own center in the silence of this shared moment. Surprisingly, many worlds we observe today in the perfect orbit might simply be barren rocks that arrived in the sweet spot far too late to start the biological clock. They reached the temperate region only after their internal geological fires had already died, leaving them without the volcanic activity or magnetic fields needed to hold an atmosphere. By the time the star's warmth arrived to thaw them, they were already desiccated corpses, incapable of utilizing the gift of the light. They are beautiful ghosts, orbiting in the perfect warmth but lacking the internal vigor to embrace it. A world must be ready for the light, its internal heart beating in sync with the external warmth of its sun. Without that internal fire, the most perfect orbit is just a path around a dead and empty house that can never be a home. True habitability requires a world that is geologically active and ready at the exact moment the stellar warmth arrives. It is a coordination of interior and exterior forces that must be perfectly timed. Many planets miss this window, becoming sterile monuments to a missed opportunity. If we were to look closer, we would see that habitability exists in the fourth dimension of deep evolutionary time. We cannot judge a world by its current coordinates alone. We must understand where it sits in the long and winding narrative of its system's history. A planet is a story that is being told across eons, a shifting entity that changes its face and its potential with every passing billion years. We are looking for a rare intersection of paths, where the planetary cycle and the stellar cycle meet in a stable and enduring harmony. To truly understand a world is to understand its age, its history, and the ticking of the cosmic clock that governs its every movement. This temporal perspective transforms our maps of the galaxy into moving tapestries of birth, growth, and decay. We are hunting for worlds that are currently in their prime, neither too young to be frozen, nor too old to be scorched. The Goldilocks Zone is as much a time as it is a place, a window of opportunity that requires a perfect temporal alignment. Our search for a second Earth is a search for a world whose clock is in sync with our own. This structure reveals that the Goldilocks Zone is ultimately a fleeting temporary state, a brief and beautiful intersection of stellar evolution and planetary geology. It is a moment of equilibrium in a universe defined by constant change, a temporary harbour that will eventually be reclaimed by the expansion of the star. No world stays in the sweet spot forever. Every oasis is eventually overtaken by the rising heat of its sun. We are witnesses to a lucky alignment, a window of clarity in a galaxy that is always in a state of becoming something else. This inherent impermanence makes the existence of a living world even more miraculous, a diamond of stability in the rough of cosmic time. We are the inhabitants of a brief cosmic afternoon, a moment of warmth between the frozen dark of the past and the searing heat of the future. Understanding this transience teaches us the true value of our own blue marble, a world that has mastered the art of staying exactly where it needs to be. It is a fragile piece, held together by the thin threads of gravity and the slow ticking of the stellar clock. We are travellers in a moment of planetary perfection. To find a true twin of our own world, we must find a planet that is in the right place, made of the right stuff, and existing at the exact right time in cosmic history. It is a triple crown requirement that demands an incredible degree of astronomical, chemical, and geological coincidence. We are searching for a world that has navigated the gauntlet of galactic radiation and remained in the sweet spot long enough for a mind to form. This alignment is the ultimate wonder of the universe, a convergence of physics and time that creates a home in the dark. Our own existence is the undeniable proof that this alignment is possible, a singular success in a vast and ongoing cosmic lottery. We are the result of a 1,000,000,000-to-1 shot that actually paid off, the inhabitants of a world that hit the jackpot of space and time. This final fact ties our journey together, reminding us that we are the beneficiaries of a cosmic symphony that has played for billions of years just to bring us to this moment. We're not just looking at the stars, we're looking at the result of a perfectly timed miracle. Every breath we take is a celebration of this incredible temporal alignment. The Goldilocks Zone is not merely a geographic coordinate in space, but a fragile temporary symphony of gravity, chemistry and time, reminding us that a temperate world is a fleeting cosmic miracle rather than a static guarantee. The Goldilocks Zone is not merely a geographic coordinate in space, but a fragile temporary symphony of gravity, chemistry and time. This realization reminds us that a temperate world is a fleeting cosmic miracle rather than a static permanent guarantee. To exist within this balance is to participate in the rarest alignment the universe has ever produced. Deep within this quiet room, the grand journey of the heavens begins to fold back into the gentle reality of your own resting form. Let the weight of your toes and the arches of your feet soften, releasing every ounce of tension accumulated through the hours. This heavy, supportive stillness rises through your ankles and into your shins, grounding you as firmly as the solid crust of a tranquil ancient world. Surprisingly, the body finds its own perfect orbit within the soft, yielding embrace of the surface beneath you. Your calves and knees grow heavy, sinking into the dark comfort like a planet finally settling into its eternal, temperate band. Allow your thighs and hips to let go of the long gravity of the day, finding the quiet equilibrium of a landscape where the winds have finally ceased. If we were to look closer at the rhythmic rise and fall of your abdomen, we would see the same steady pulse that governs the cooling of a newly formed core. Your lower back and spine release their hold, melting into the shadows as if returning to the dust from which all matter was born. A sense of deep, internal warmth serves as a localized sanctuary, a small and precious pocket of peace in a vast and silent dark. This deep release moves into your hands and fingers, which rest as still as the frozen plains of a distant moon. Every muscle in your forearms and elbows grows slack, surrendering to the pull of the surface that holds you. You are perfectly centered, perfectly safe, and perfectly at rest within the wide architecture of the night. Your shoulders melt into the pillow, feeling the deep release spread through your neck and into the base of your skull. The jaw slackens, the eyes grow heavy behind closed lids, and every muscle in your face smooths into a state of total, effortless surrender. Focus entirely on the sensation of the fabric against your skin, a gentle and familiar weight that anchors you in the here and now. The rhythm of your breathing is the only clock that remains, a slow and steady measure of the peace you have found. Every inhalation brings a deeper sense of heavy comfort, while every exhalation carries away the last fragments of the waking world. Your mind is a calm and empty vessel, drifting through a sea of soft velvet darkness where nothing is required of you. The bed is a perfect harbour, a place where the light is dim and the silence is absolute and kind. You are safe, you are warm, and you are ready to fade into the deep restorative currents of the night. Everything is still, everything is quiet, and the weight of your body is a comforting anchor in the velvet dark. The pillow supports you with a gentle, unwavering firmness, inviting you to let go of the last threads of thought. You're drifting now, floating in the softest of shadows, where the only sound is the quiet, rhythmic echo of your own peace. The world outside has faded away, leaving only the warmth and the stillness of this moment. And now, 101 wonders are resting with you. Sleep now. Good night.